Here is another question, which is scenario based question of May-June 2018, in which a stopwatch unit 6-digit to display hours, minutes and seconds, and here the Denary value of hours, minutes and seconds is given. An 8-bit register is used to store each pair of digits. Means you just need to convert each Denary value of hours, minutes and second into an 8-bit binary register. So Denary value of hours, so it is 02, and we will divide it by the factor of 2, so it will be 1 and the remainder will be 0. Now we just need to write the remainders, so it is 1 0 and the remaining bits will be 0 in order to make an 8-bit register. How it is done, so it has been previously mentioned in my previous lectures. Now next is the 31, and if we divide 31 by the factor of 2, so it will be 15 and remainder is 1, and then 7 and the remainder is 1, then 3 remainder is 1, and finally 1 and the remainder will be 1. So we will read remainders upward and write from right hand side. So and the remaining bit will also 0 0 0 in order to make an 8-bit binary register. Now the third one will be 58. If we divide 58 Denary value by the factor of 2, so it will be 29 and the remainder is 0, then 14 and the remainder is 1, then 7 the remainder will be 0, and then 3 the remainder will be 1, and then 1 the remainder will be 1. Here 2 bit places are empty, so we just need to write 0 in empty place in order to make an 8-bit binary register. Now move to the part 2 of this question, part B. The stopwatch is started again and then stopped. When the watch is stopped, the 8-bit binary register show hours, minutes and second, which is basically in binary number. So write the Denary values that will now be shown on the stopwatch. So you just need to convert these binary numbers of 8-bit registers into Denary value and just write the answer exactly the same that matches with the pattern of the scenario. Here how we will do this, so I have told you in my previous lecture. So here I am quickly convert this binary number into Denaries and just write positional value for each digit. So it will be 1 2 4 8 16 32 64 and 128, which you have to learn and keep in mind during your exams. So just cross out a value under a 0, and finally so we need to cross out 2 8 16 32 64 and 128, and finally we just add the remaining positional values, which is basically under a 1 digit. So if we add 4 plus 1, so it will be 5, and you know we have to follow the pattern. So in digital watch we need to write the answer in pure for hours, so it will be 05, right? Now next do this exactly the same for minutes. So if we write these binary numbers and write its positional values same as, so we need to cross out a value under a 0, so we will cross 1 4 32 64 and 128, and the remaining positional values will be added according to rule. We will add 16 plus 8 plus 2, so it will be 26. So we will write in the place of minutes. Now move to the third part. If we convert the binary register into Denary for seconds, so it will be we just need to cross out a value under a 0, so we will cross out 8, then 64, then 128, and finally we will add the remaining positional values. When we add 32 plus 16 plus 4 plus 2 and plus 1, so it will be equals to 55. right? So this is the way that how to attempt this question. Hope you understand well. Now here is a question of past paper of October-November 2015, and there are several parts in this questions basically, but we will right now solve questions related to the binary and denary number system, while other will be discussed later according to the sequence of topics. Now the question is, sensor and a microprocessor monitor a car exhaust for high temperature and high carbon monoxide CO levels. The information from 7 sensors is sent to an engine management system in the car. The status of each sensor is stored in an 8-bit register. A value of 1 indicates a fault condition. So here an 8-bit binary register given, and under each bit place status is defined. Remember, if bit is 1, the current status is active or the condition is true. And according to question, you just need to write fault conditions which is currently happening. So let's solve part 1 of this question, in which identify the fault conditions that the following register indicates. Here 8-bit register is given, and you just need to place these bits in status defined register. And remember, 1 indicates fault condition. So here is 1. So the first fault is CO level too high, and here is 1, so it means oil pressure is too low. And finally here is 1, so it means brake pads too thin. So these are 3 faults according to part 1 of this question. Now move to the part 3 of this question. A car has a faulty airbag and the CO level is too high. Write what should be contained in the 8-bit register. So here the conditions are given, and 8-bit empty register is also given, and you just need to match these two conditions with the status defined register. And where it match, you just need to write 1. So here the condition is faulty airbag, and it matches with the status airbag fault, so write 1 here. And next, another given condition is CO level is too high, so this condition is matches with the status CO level too high, so write 1 here. And finally write 0 in remaining empty bit place. So this will be your answer. Hope you understand well. In my next video, I will continue the topic hexadecimal number system. Stay connected with the channel, like and subscribe Learning Factor, and learn a lot.